Ladies and gentlemen, my name is Subrata Sarker. I'm a mechanical engineer working in manufacturing industry since last 22 years. Today I'll discuss a very special topic, Six Sigma methodology. Before going into the subject, I'll take you through some, and just want to give a feel that the complexity or criticality of the engineering. You can see the picture of a rocket engine. As the picture is of NASA actually. The engine is now going to be assembly shop for assembly. You can see there's so much of complexity. There are thousands of components in the engine. Now if there is any quality issue on any of the component, finally the rocket will not function as per it is desired, isn't it? Now who will ensure this engine is perfect, or as a whole there are a lot of components altogether will come and make the complete rocket? So who will ensure that? Is it one a quality control manager or quality assurance department can make it, or the different company or source? Who can actually ensure? You can't catch hold in a single person if it doesn't work or there is something malfunctioning, isn't it? And you can imagine the cost actually behind this. A rocket will be launched, so much of cost. Is just a 1,000 crore cost actually in terms of time and the importance. So there are a lot of other intangible actually, rather you can say the cost is. Now I have got the opportunity to say this aviation industry or some high-end manufacturing industry from very close. I've been working in Germany in 2006 and 7 in a company called Wutzenmann GmbH. As it was in South Germany. Wutzenmann was basically a manufacturer of metallic bellows expansion joints, flexible metal joints actually, which are also needed in aeronautic engines, like from the fuel to fuel feed section. Somehow this Wutzenmann was supplying these components to the Rolls-Royce engine for this Airbus A380, and I was a part of the project. So I did a lot of learning was there actually. At the time, I got the feeling of the Six Sigma. What is Six Sigma and why it is needed? Like this actually, the some tip of those experience I'm going to share today. You can imagine this, like what is the criticality of components and the total quality of this aeronautical and aviation industry, and what is the reliability requirement. You can see there's a visual of this engine actually. This engine, rocket engine actually, aeronautics. It's a Rolls-Royce brand actually. Engine is supplied by and this fitted in A380 Airbuses. So there are thousands and millions of components, and if there is any defects in any of the component, it will not function as per the requirement. So who will ensure the quality is perfect? You can see this is a cross-sectional view of the engine. Is a 3D model design of this engine actually. So you can imagine that there's so much of complex things actually. It is as individual or by some normal process of quality assurance, you just can't handle this. It is much above of that. I also have been in Singapore, and I have 2 times. I have closed the Singapore Tower from engineering or technical point of view. It is just a height of reliability. The things are made in such a way, this engineering reliability, you just can't imagine if you don't see it physically. Now, I can't start talking about this, the Six Sigma from the anyhow, because it's not a subject here, it is a subject here. So, if you want to discuss some topic on master degree, you cannot discuss it with the primary school student or the topic of the primary actually, what I meant to say is. So a company, if they wish to implement Six Sigma, they can't start it from tomorrow, because it is not a starting point actually. It is somewhere here. You have to go step by step, a lot of things, then only you can reach Six Sigma, and then you can enjoy the result actually. So steps are like, the how to go actually that level, steps are like that. Here you can say step by step. Number one is, 5S is very important. 5 is this organizing things like which is not needed, separating, and keep the things very systematic way, keep cleaning, keep the system organized. So this is you can see another videos of mine which is only about the 5S, so you can have a better idea if you go through that video too. Then doing after 5S, then Kaizen, then lean manufacturing, then you can reach to the level of Six Sigma. Now let's have some very basic understanding what is 5S and all those to reach to the Six Sigma discussion level. And basically in Six Sigma methodology, the focus is on, these are the three things actually: the quality and speed and result has to be, improved drastically and every time, and cost also has to be cut down. So this is basically the objective of Six Sigma implementations. So as I said, the first step is 5S. 5S is, one is sorting. So in your factory, in your environment, when things are not needed, you remove those things. Then straightening, it means according to the category, give the things properly, systematic way in your factory, in your organization. Then shining, third is shining is you need to maintain cleaning these components every time. Then standardization, and then for sustaining the system continuously. Then second step is Kaizen. Kaizen is Kaizen is not a single thing actually. Kai means change in Japanese language and Zen means good. So change for improvement, Kaizen means. There are a lot of things that are interconnected in Kaizen. So that Kaizen culture has to be adopted in the organization to reach to the Six Sigma level. So in Kaizen, the TQM, TPS, there are a lot of things actually you have to do actually. Few of them are like, one is called just in time. Just in time is used in mostly, this concept is implemented rather, I can say, in automotive sector. Suppose you are manufacturing a car and a lot of components coming from different suppliers. So you should not store or do the inventory of the components for months or weeks and put into the assembly line. Things is when required, it will come on that time only. So your inventory cost will be reduced. There are a lot of other advantages. So just in time means when things is required, it will come on that time only, not before that, and not after that also. So it is a very it's not so easy actually. I can say a lot of supply development controls is needed for implementing this JIT, just in time, which is used very much popular in automotive sector. Otherwise, it's not possible to manufacture such a this mass production kind of things. Another is called Zidoka. This another steps actually is a part of the Kaizen. In Zidoka there are three main things. One is the Pokayoke, one is the Andon, and another is the automation. Pokayoke means sometimes there are many things which are human skill dependent. So for this making these things foolproof is called Pokayoke. You can see a simple example here. There is a positive and negative side of the plug and pin. So if you change this way, so it can, there will not be any mistake actually. So mistake proof things. And Andon means visual display on the shop floor. So what is going on the shop floor, which things is which stages, where it is stuck up or is moving perfectly. So anybody and everybody can visualize this. And the automation things are also very much important for this Kaizen applications. I think now we can discuss what is Six Sigma methodology. It has got DMAIC. It's called the define, measure, analyze, control, and improve. This is the cycle of Six Sigma actually. Now in define mean you have to select some projects. This is there are total 11 steps for Six Sigma methodology DMAIC. Measure means establish a performance parameter for the project which you have taken. Then next step is validate the measurement system. Then the measure and this analysis. Then the analysis parts will come. Analysis parts you have to establish the process baseline. Then define the performance goals and identify the variation, where the variation is coming. And the fourth is the improvement. Next step is improvement actually. This improvement is the explore the potential causes. Which are the main potential causes to control this quality? The variation, the relationship of the variation with that, and design of the operating limit. You can say here the step 6, 7 and 8. And now the next method is improve. And improve, you can say the validity, measurement of the system, verify the process, and implementation process. So overall, this define, measure, analyze, and improve, and control, altogether there are 11 steps in Six Sigma. And there, I'm not going to discuss much on this. This is very subject specific and typical, so how this is maintained and doing all these things. Now, this important slide is, this is very, DPMO. DPMO means defects per million of occurrence. If something is achieved 99%, we think we have achieved very good, but 99% is nothing, in terms of Six Sigma actually. Six Sigma talks about 99.9997%. And if you like to understand what is the difference between, achieving 99% and 99.99997%, I'll give some example. Say 5,000 surgical mistake in each week. That is, if that is the 99% level, then 99.99997 Six Sigma level is 1.7 surgical mistake in a week. 15-minute unsafe drinking water per day, if that is the level of the water supply system at the present and achieve 99%, then Six Sigma level if they achieve, then 1 minute unsafe water in every 7 months, that will be the level. Another example, for 7-hour load shedding each month, if this is the level of the electricity company who are supplying the electricity, and achieve 99%, if they achieve 99.9996%, that is Six Sigma level, then 1 hour load shedding will be in 34 years. So there are a lot of other examples of that. So you can imagine the difference between achieving 99% and achieving Six Sigma level. There are very common points with the Six Sigma and Kaizen. Also, many types of people are, get mixed with the Six Sigma and Kaizen. This is not like that actually. Kaizen is basically depends on the people, the human dependent, and Six Sigma is, it is a process dependent and is a costly process also. Kaizen is not always costly. And there are levels also, those who will be implementing this, handling this Six Sigma. This is called yellow belt, green belt, black belt, master black belt champions like that. And you can see this pyramid. And by the way, I'm one of the Six Sigma black belt. I did it from International Certification Authority, Six Sigma black belt. That's why it is one of my interesting subjects. There are many companies like GE, Xerox. Those companies are all Six Sigma implementing. Actually, they are practicing company actually. So Six Sigma is basically the benefits are it's a focus on customer. And its customer loyalty improve, your cycle time will improve, your waste will improve, your customer satisfaction will be improved, and systematic problem solving. There are a lot of good things in the organization will come if you develop this Six Sigma methodology in your organization. But it's not so easy. As I said, you have to go step by step actually, like 5S Kaizen and all these things. Then you will be in a position to implement Six Sigma. Thank you very much for your attention.